We're going to take a quick look to see if you remember from your previous education the mean, median, mode, range, and outliers from a list of data. So I have here a list of 3 different people's data. All 3 of these people are working the phones and they're soliciting donations for a charity. So if we use Biff's data list, we know on day 1 he had 13 donations. On day 8 he had 20 donations. So if I take a look at this whole list, I can start off by getting the mean or the average by adding up all of these numbers and dividing by 11. So if I add those all up, it's 202. 202 divided by 11 is 18.4. He averages 18.4 donations a day. The median is the middlemost number, and the way you do that, as long as your data is in order, you cross off the lowest and the highest, then the next lowest and the next highest, and you keep crossing off the lowest and the highest until you arrive at the one in the middle. So the median, 19, is the middlemost data point, meaning there's just as many days that he has fewer donations as just as many days that he has more donations. If it turns out that, we'll get to that a little bit later. The mode is the most frequently occurring, so I can see that 20 occurred twice. No other number of donations occurred more than twice, so the most frequently occurring donation is 20. And the range is the distance from the lowest donation to the highest donation. So to get that 12, we said we went 25 minus 13 equals 12. His range is 12, meaning the difference between the smallest and the largest number of donations is 12. You could carry out the same idea with Wally's data and Pocoroba's data, and you would get their mean, median, mode, and range. One thing now to point out, though, is an outlier. An outlier is a data point that seems unusually different than the rest of the data pieces. So if you look at Pocoroba's data list, 13, 14, 15, 16, 17, lower 20s, all of a sudden 125. That 125 is an outlier, and that's going to be changing some of the measures that you have. For example, look at now, he has a crazy range compared to the other people, and even his mean seems unusually large. Those are based on that outlier. Wally also has an outlier. He has a 0, which is unusually low compared to the rest of the data pieces. So here's a quick example to show you about an outlier and the outlier effect. This is a list of the number of absences a student had during their 13 years maybe in high school, in their education. So in kindergarten they had 2 years or 2 absent days. This would be first, second, third, fourth, fifth, sixth, seventh grade. Maybe they had 6 absent days. And notice that one of the years they had 75 days absent. So this has already been put in order. So you could go through and cross off the lowest and the highest, the lowest and the highest, the lowest and the highest, and you'd find the middlemost number is the median. And you'll notice that the range is 73. We go from the smallest to the largest at 73. But if you took out this outlier and say, for some reason that doesn't seem to represent what happened to this student during the rest of their years. Perhaps maybe there was a family emergency and they had to miss the second semester. Who knows what happened? But if we say that wasn't representative and take that out and pretend that your data list was really going from 2 to 11, now some things would change. If I recalculated the mean by just using those numbers, I would get a 5.8. If I just used those numbers and I recalculated the median, it would turn out that it wouldn't really change. It would stay at 5 if I started crossing off lowest, highest. The mode also would not change. but the range would change because now instead of going from 2 to 75, we would go from 2 to 11. And what this is called is the outlier effect. And what that means is when you have an outlier data piece, if there's a good reason that you say that doesn't represent the main trend of the data, you can take that out. When you take that out, the mean is very likely to be influenced and the range is very likely to be influenced. But the median either does not change or changes very little when you take out an outlier. So the median is called resistant, where the mean and the range are not resistant. They will change a lot.